Okay, now we're recording. So we need to simplify this circuit. I'm going to combine these two because these are in series. So when you're next together, you're in series. This is the easier type to combine. You combine these simply by adding them together. So 300 plus 100, that gives me 400. So basically I can simplify this circuit to something that looks like this. Yeah? Speak up? Why?
Because in the video you can't hear me.
I'm talking loud enough. The microphone's in front, like right here. Okay, that was Daniela Landa. So I just added those. You get 400 here, and the other one is still 500. Okay, so I added these. This is series. When they're side by side, you just add them. When they're not side by side, when they're parallel, this is going to be a little bit different. When you're adding parallel, the equivalent resistance looks a little bit different. You're going to do 1 over R equivalent is going to be equal to 1 over 400 plus 1 over 500. Okay? And you're most likely going to have a calculator on this. So 1 divided by 400 plus 1 divided by 500. You're going to get a decimal. If you want to, you can try to change it to a fraction. It's not necessary. So you're going to get some sort of decimal. I'm going to do the decimal one because sometimes it's like that. So you get some sort of decimal. That is not your resistance. That's 1 over your resistance. So to find the actual resistance, you're going to do 1 over that answer. And to be as accurate as possible, you're going to do 1 divided by, and then you can hit second answer, or whatever that decimal is. So then the equivalent resistance would be about, I'm just going to keep it at 222 ohms. So that's how you deal with parallel. And now that I've simplified it twice, this circuit looks really easy. It's pretty much the same. Oh, I have those backwards. You get it. So that's ultimately what you see. It says find the total current in the entire circuit. So if I know that this is 220 ohms, this is 120 volts, this is resistance, this is V, I can use the equation V equals IR. Okay, so I'm trying to find the current, which means I need to divide by R. So I equals V over R. I have 120, and I'm going to use the equivalent resistance of the entire circuit, which is 222. So that is going to give me so not a lot of current, about 0.54 amps. And then how much voltage does R1 see? R1. Okay, so this goes back to the question of how voltage splits up in a circuit. Voltage, this is kind of like a house where voltage will go to R1, this branch, and this branch. It'll apply equally. So 120 volts goes to both branches of this circuit. So without doing any work, you know that this is 120 volts. Okay, voltage stays the same when applied to parallel circuits. No work done. How much current runs through point A? What does change is current, however much current we have running through here, which is, we said 0.54 amps. That current does split up between these two. Now, we know that there's less resistance between these two, so there should be a little bit more current going through there. So to find how much current goes through there, because we're looking at point A, so how much current would go through this branch? There's 400 ohms of resistance there. We know how much voltage is there, so we just use the formula. So how much current, voltage, resistance. We know it's the same voltage, but this time there's only 400 ohms of resistance in that bottom part of the circuit. So 120 over 400. 0.3 amps. So notice it's less current than in the entire circuit, and a little bit more current because there's less resistance. Then the last question, how much voltage does R2 see? So this is a tricky question. R2 is next to another resistor. How much do both of these receive? We know that they both receive 120 together. But voltage, when it's applied to series, splits up. So we're going to use the V equals IR. We know how much current is going through there. 0.3 from the previous part. And the resistance, the amount of resistance that R2 has is 300.
Well, you're saying the current split?
Okay, so calculate this. This is a pretty easy calculation. Should be 90. So 90 volts. So notice that is a smaller amount of the voltage that actually goes through there. So 90 volts goes through that. Here's a screenshot of the entire problem.